So we've talked about linear equations and we've talked about how we want to think about these linear equations. The way we basically want is we want to separate the x component, the y component, and the z component. It's a three-dimensional equation. And then we want to think of the solution as a linear combination of these vectors, right? And now let us look at how we would go about finding the values. And the idea comes from a mathematician called Gauss, and this is called as the elimination method. So the way you would actually do it, right? So if let's say, so this is the equation we have that we want to solve, but let's say we just take a simple equation. Okay, I'm just trying to show you what the basic idea of elimination is. Yeah, this. So let's say I have an equation that looks like this. Okay, and I want to solve it. How do I solve it? Okay, and you've probably done this, and the way you would do it is basically eliminating a variable, which is very simple. And the way you do it is it's like this. So if this is my equation 1 and this is my equation 2, right? Then here's what I'm gonna do. I am gonna do this. Look, I'm gonna say that I am gonna multiply equation 2 by 2. So 2 times equation 2, right? And I am gonna subtract. I don't really need to subtract over here. I'm just gonna add equation 1 on top of it. Okay, what does that look like? So 2 times equation 1 is basically minus 2x. Okay, so I think I should make it much more obvious by adding these, right? And then what I'm gonna do now, add 2x minus y equals 0. So let me actually solve that. That is negative 2x plus 4y, and that's going to be added. 2x minus y is equal to 3 to the 6 plus 0, right? So what this basically does is my x variable is now eliminated. It's no longer there. And I get 4y minus y is equals to 6. That is 3y is equals to 6. So my y turns out to be a 2. Okay. And now what I basically do is, because I have the value of y, I go back to one of these equations, right? And I'm going to put that value in. So for example, let's say I'm going to take this equation. So that is 2x minus y is 0. And if I know that my y is a 2, then my x would be something like this. So therefore, I come up with x is equals to 1 and y is equals to 2. And that is how you would basically solve this equation. Now, every time if I have to do this, right? So the basic reason we invented matrix form is because I didn't want to look at this dirty, like disgusting, basically this disgusting equation where you have x's and y's flying around everywhere. So I'm not going to do that. I'm going to do this in the matrix form. So let's say I had to do the same solution in matrix form. How would I do that? So let me write that equation down over here. So I'm no longer going to look at this ugly, hideous equation. I'm just going to look at its matrix form because that's much easier to look at. It's much cleaner, right? And now I don't need to think about x's and y's, so I'm going to get rid of x's and y's. I do need this thing over here, because if you realize that I have to do the things that I did over here to this as well. So I'm going to do that, and I'm going to create a new matrix, which is basically, it looks like this: -1, -1, 2, 0, and 3. Okay. If I were to write matrix like that, I wouldn't really know that 0, 3 is a part of the result. So what I can do is I can basically, let's say, create a line over there, or I can do this. Okay, so let me just do this because it looks easy. So it's just to separate that this column is actually the result. So over here, we're gonna do the same thing as we did over here, which is basically I want to make this -1 over here go to a 0. So how do I do that? We already know how we do it. So let's say that this is my row 1, this is my row 2. So what I want to do to my row 2 is I want to make my row 2 2 times row 2, right? Because that's what we did over here, if you remember. And then I'm gonna add row 1 to it, and then I'm gonna do r1, r2 is equals to r2 plus r1, right? It's basically the same thing. Doing this is the same as doing this. Does that make sense? Okay, so I'm just gonna do one at a time. So let's say I just do this right now. So when I do this, I'm gonna get 2 minus 1, 0, minus 2, and this is gonna be 4, 3 2s are 6. It's kind of the same thing. And then I'm gonna do r2 is basically r2 plus r1. Okay, and I'm gonna get 2. Now, so the first column doesn't change, right? The first row does not change. The second row does change, and that becomes a 0. So when I add these two, this becomes a 3, right? And when I add these two, this becomes a 6. Okay, so now we've ended up in a place where we have something like this. Okay, and if you just look at this over here, so what we essentially have is something called an upper triangular matrix. So if I just look at this, so I just say that 0, 6 does not exist, and that is a upper triangular matrix, right? And I can do the same kind of solution here now. So this 3 is basically the component of y. So I can say that 3y is equals to 6. So y is basically 2 again. And I can do the same thing over here now, which is I can substitute the value of y in one of these equations. So that is 2x minus y is equals to 0, and we know that y is 2. This is basically a substitution, and therefore we have the value of x to be 2 divided by 2, which is 1. And that is how you solve it in matrix form. Now, if you look at this matrix form, it is much more cleaner than thinking about this weird equations, right? And that is basically why we use the matrix form. Okay, now that we know how to solve this in 2 dimensions, let's think about solving it in 3 dimensions. Okay, and for that I'm gonna use this equation. I'm gonna copy that, I'm gonna paste it over here. There you go. Right, so if I were to do the same thing just with the equations for this thing, then it's just gonna turn out really hideous. But instead of that, what I'm gonna do is I'm gonna use a matrix form. So let's write it in matrix form. So in matrix form, I know that I am supposed to list out the values of x in the first column. So that is 1, 3, and 0, because there is no x in the third equation. And you're going to do the same thing over here now. And then I'm going to separate out the x, y, and z's. And then I'm going to have 2, 12, and 2. Great. So now that we have this, we can follow the same thing that we did before, which is the elimination method. And I'm going to create something called a augmented matrix. So this is just a name that I'm giving to whatever we did over here. So over here. So this thing that we created over here, right, which was the combination of this and this, that I'm going to name it as a augmented matrix. So I'm going to do that over here now. So the augmented matrix would then look something like this, and 2, 12, 2. Okay, right? So how do we do it now? Well, I know what we want to do over here. I don't want to touch the first row. I just want to make this thing, this 3 over here, go to a 0. So how do I do that? I basically do something like R2 is basically R2 minus 3R1. Okay, and when I do that, I am going to get something like this. 1, 2, 1, and 2 remains unchanged. This is going to be a 0 now because that's what we want to do. And I'm just going to do 3 2s are 6, so 8 minus 6 is a 2. 3 1s are 3, and 1 minus 3 is a negative 2. And what is this? 3 2s are 6, so 12 minus 6 is a 6, and nothing else changes. Okay, does that make sense? Great. So if this was a 2 by 2 matrix, it would have been done because this thing was became a 0. But because it's a 3 by 3, you still don't have your solution yet. Okay, and now what you want to do is you want to take this over here, because this is already a 0. You want to make this thing a 0. Okay, so basically what you're aiming for is a upper triangular matrix, which we did over here. So this was an upper triangular matrix because below this diagonal, right, everything was a 0. So for a 3 by 3 case, this over here is the diagonal, and I don't want any the diagonals to be a 0, but I want everything below the diagonal to be a 0. So this is a 0, this is a 0, this is not a 0. So let me make that a 0. And the way I would do that is I'm going to do R3, and I'm going to use the second equation to do it, because the second equation already have a front to be a 0, which means that anything I do to this won't affect this first one. So I'm going to do R3 is basically R3 minus 2R2. Okay, and when I do that, I'm going to get something like this. 0 to negative 2, because I'm not changing any of those 2 rows. So something interesting happens now, and that is R3 is a 0, R2, so this is a 0. So this is not going to change, that's going to stick as 0. That's what we want, because we want a lower triangular matrix. And you have this 4 that goes to a 0 now, because we designed this in a way to make that 0. And now you are gonna have this, so that is R3 minus 2R1. So 2R2 is basically 2 times 2, which is a 4, minus minus plus, so that's a plus 4. So 4 plus 1 is a 5 now. And then you're gonna have 6 2s are 12, so minus 12 plus 2, which is a minus 10, if I'm not wrong. So there you go. So now we have this, and we know what that means. That means that 5z is equals to negative of 10, right? And there you go. If that is the case, then we know that z is negative 2. I can go back to the same matrix and then just substitute. So the second row of the matrix states that 2y minus 2z is a 6. So 2y minus 2, z is a negative 2. So I can do 2y plus 4 is a 6. So 2y is equals to 6 minus 4. That is y is equals to 2 divided by 2. That is y is 1. I can do the same thing over here in the first row of the matrix, which is x plus 2y plus z is a 2. And I don't know what x is, I know what y is, and I know what z is. So z is a negative 2. And that is x plus 2 minus 2 is equals to a 2. So x is 2. So therefore we have our answer. Z is a negative 2. And there you go. So this way you have essentially learned to solve a three-dimensional system of linear equation with three unknowns. And so this matrix, writing it in terms of matrix just made our job a lot easier, because if I were to do the same thing with equations, then my head was just gonna hurt more. And that is basically how you solve a system of linear equation using elimination method.